So we're calculating determinants of matrices of any size, and we chose a size 3 by 3. And we found that for any matrix, to find the determinant, multiply any element in a row or column by its cofactor. Well, we didn't really discuss how to calculate this cofactor in a lot of detail. We just kind of presented it to you and told you it was the cofactor. So a cofactor is represented maybe by a sub ij for row and column. This equals minus 1 times I plus j times the minor matrix. So this is the minor, and this is a minus 1 or a positive 1, depending on whether this is even or odd. And what this ultimately ends up doing is you will end up with a situation where you'll have 1, minus 1, 1, minus 1, 1, minus 1, 1, minus 1, 1. Ones will alternate in minus ones like this for a 3 by 3 matrix. And if you had a larger matrix, there would just be more ones and minus ones. So when you choose the row, like we did up here, when we choose the row, say the bottom row, and we select an element, this 1, we're going to take 1 times the cofactor. Well, the cofactor is going to be, since we're here, is going to be essentially 1 times the minor matrix that is created, 1, 0, 2, 1. So that's why that happened. And when we choose the 0 here, this is 0 times, and the reason this is minus 1 is because it's this guy here, but it really is minus 1 to the I plus j, or third row, second column. So it's minus 1 to the 5, which is going to be odd, which is going to make this a negative 1. And then our determinant of the minor was 1, 0, 2, 1. 1, 0, 2, 1. So that's how we did that. I'll do another example of this with a larger matrix to show you how we set this up. Then I'll show you an easier way to do a 3 by 3 matrix. So say I have a determinant of a 4 by 4 matrix here, and I want to calculate what it is. Well, let me set this up for you. What you're going to solve then is we're going to choose a row or a column. And I like this row right here because it's got 2 zeros in it. So that's going to make life easier for us. Okay? So I'm going to end up with 0 plus, or 0 times, the associated cofactor, plus 0 times the cofactor, plus the next number is 1 times the cofactor, plus 6 times the cofactor here. So our cofactors then, so our first one, we're going to essentially, here I've written the relationship for the cofactors again. So For this, then, I'm choosing this row. This green line here is the row I chose. So I'm going to start creating the minor matrices and the plus or minus 1 associated with it. So the minor matrix here for when I block out the red column here with the line is going to be the minor matrix left over of 2, 1, 3, 2, 2, 0, 1, 2, 3. We don't count this row because that's the row we chose. 1, 2, 3. That's our minor matrix. Now, then it's either going to be multiplied by a plus or minus 1 depending on its position here. So this is going to be minus 1 to the I plus j, which is third row, first column. So this is going to be third row plus the first column. It's going to be an even number, which means this is going to equal 1. So this is 1. All right. Next, we're still doing this row here, but now I got to choose the next column to mark out. And now our minor matrix is 4, 1, 3, 4, 1, 3, 6, 2, 0, 6, 2, 0, and then 6, 2, 3, 6, 2, 3. And this is going to end up being minus 1 because it's third row, second column, and minus 1 raised to the 3 plus 2 is minus 1 to the 5. Okay. Next we have this, which leaves us with a minor matrix of 4, 2, 3, 6, 2, 0, 6, 1, 3. This is going to turn back positive 1. So these always alternate 1, minus 1, positive 1. This one will end up being minus 1 here. So now I cross out this last row, and again, this is going to end up being minus 1. The minor matrix then is 4, 2, 1, 6, 2, 2, 6, 1, 2. Okay. So then you have to figure out the determinant of a 3 by 3s. And you got to go through this process again, where you choose a row for each of these and the cofactors. And oh man, this is laborious. But if you go through all this process, you're going to end up with minus 42. So for large matrices, it can be kind of rough figuring out the determinant by hand. What you can do, though, is you can use an application, and applications are easy to find. You just type in determinant calculator into Google, and it'll pop up. And typically, you just throw the matrix in and say solve, and it'll give you the determinant. So we could just run up to Google, type in determinant calculator. I actually had it already saved, and a whole bunch of different ones pop up. I always usually choose the first one and see how it looks. First one pops up here, and over here on the left on this one is where you choose. Also, you could do the inverses here, like we did before. But here's the determinant. So now you got to choose your. Oh, okay. So it comes down here and it tells you how to set this up. So I don't see 4 by 4. There it is. Here's a 4 by 4 determinant. And let's put in our values here. And then hit the button. and it says the determinant is minus 42. So I'll show you another way to do 3 by 3 matrices. So if we're going to get the determinant of this 3 by 3 matrix that we did before with cofactors and minor matrices, what you do is you take the first two rows, first two columns I mean, and you rewrite them over here to make a bigger situation. Now what you do is you multiply all the numbers on this diagonal and add them to the product of all the numbers on this diagonal and add them to the product of all the numbers on this diagonal, like so. 3 times 2 times 1 plus 1 times 1 times 1 plus 0 times 2 times 0. Then you go and you subtract the products of these diagonals. Whoops. Actually, start here with this one. So you always have three numbers, this one and this one. So it's minus, so 1 times 2 times 0 minus 0 times 1 times 3 minus 1 times 2 times 1. And you just add those up. You might think this is easier than the cofactor method, but it really doesn't take any less time if you understand the cofactor method. The cofactor method you could really do pretty quickly. So simplifying this, we get 7 minus 2 equals 5. Same answer that we got before. So keep in mind when you use this cofactor method that you can do these quickly in your head when you get the hang of it. So the cofactor method actually does not turn out to be necessarily any longer or more complicated. Well, I guess it's more complicated, more to remember how to do it than this simple idea I had down here. And of course, you'd have to do this if you did 3 by 3 matrices or this 4 by 4 matrix. You would have to do these multiple times for Cramer's rule. For example, say you had this system of equation to solve. So now it's 3 variables. So x equals. So now you've got to create the determinant. So the denominator, actually, let's do that one first. The determinant of the denominator is just the matrix associated with the coefficients on the left side over here. So this is going to be 3, 1, 0, 2, 2, 1. So 2, 2, 1, and then 1, 0, 1. 1, 0, 1. So that's the determinant on the bottom. And then on the top here, because we're doing x, we're going to replace the x coefficients with these numbers over here. So it's 5, 7, 2. And then the rest is the same. 1, 2, 0, 0, 1, 1. So that'll give us what x is. And here's the relationship for y. I replace the y row with these. The denominator is the same as up here. And then z, I'll just do over here. And this is z over here, where I place the third row with the 5, 7, 2. So you can calculate these. Now notice if you calculate these, like say you figure out what x is, you could go in and use substitution to figure out what z is really quickly. And if you do these if you calculate these, and I suggest you do to practice, you'll see that x equals 1, z equals 1, and y equals 2. So if you were to do the first one here and find that x equals 1, you could stick it in this equation and quickly find out that z equals 1. And then if you know that x equals 1 up here, you could put it in this equation and quickly find out y equals 1. So doing all this is not always necessary. If you're solving this for some work you're doing in the lab or something. So anyways, that's Cramer's rule. Now, of course, if we had four variables, these would be 4 by 4 determinants.